Hi Hires, problem solving question from the 2014 SQA paper, question 12. This is an experimental design question. Okay, context. An investigation was carried out to study the effects of exercise on sweat production in humans. Lovely. Exercise bike placed in the lab with constant humidity and temperature. Healthy 30-year-old male exercised in the bike for 5 trials of different durations, and they're going to give you a table of that. The average rate of sweat production during each trial was calculated. There was a recovery period after each trial to allow sweat production to return to normal, and the results are shown in the table. Here's our table. So we've got our 5 exercise trials with our different durations, running from the first one at 30 seconds up to the second one at 150. And then we have the average rate of sweat production in milligrams per centimetre squared of skin per minute. Okay, first thing you're asked for is a graph. On the grid below, draw a line graph of average rate of sweat production against the duration of exercise. You should now recognise this as standard. Choose an appropriate scale to fill most of the graph paper. They have given you, though, the first point on the x-axis because they're expecting that it's not going to start at 0. And that's totally acceptable at higher. Okay, so we're starting at 30 going up to 150. So let's see if that was 60, 90, 120, 150. No, that's not going to be good enough because that's using less than half the scale. So if we went up in 15s, so 45, 60, 75, 90, this is looking better. We were going 105, 120, 135, 150. Yeah, you're going to have to go there. Okay, and going up the way, we have average rate of sweat production. That has to start at 0, I would say, on this one. We're going up to 0.45, so that's if that was 0.1, 10 to make it easier to when you're doing it. So that's 2, 3, 4, and 5. Okay, and then we need to join the points properly. So 30 is going to be 0.1, 60 is going to be 0.21. Remember, you can go to half box tolerance as expected, so it's going to have to be between the two. 30 is 0.32, 120 is 0.43 again. You've got to be between the lines, it's got to be clear to the marker that it's between the lines, and 0.45. Like, same deal. Oh, I keep on getting up a thing I don't want. There we go. So make sure, see, the marker has to go through and literally go, yep, that's a decent mark, yes, that's in the right place, yes, that's in the right place. Oh, and that one just didn't come up at all. Where we're going, that was 4.3. There we go. And then your join must be neat, which I really can't manage on this. So you would be using a ruler to join these neatly. Okay. Oh, sorry, you wouldn't get the marks for this. I'm assuming you've noticed the massive glaring gap here and here. You just lift this from here, take the entire thing down, put that there, take the entire thing and put this here, like every single bit of this. Don't miss out any word. Okay, so we are asked to give 2 variables, not already described, which should be kept constant to allow valid comparison of the exercise trials. Okay, so what have we got that we are not going to be able to change, right? So we're told who it is, so it's going to be the same person, so we can't change that, that's fair enough. We have constant humidity, and we have constant temperature already stated, that's fair enough. So we've got to look at what we can talk about for this one. Okay, so this bit has potential. It says a recovery period. What do they mean by a? That's going to have to be more clarified. So the length of recovery period could be reasonable. The sweat production on this healthy 30-year-old male, well, the exercise, it says different durations, but you're going to have to be more clear about that if you were going to actually say this was an experiment. You would have to say to the person, you're going to pedal as hard as you can for 30 seconds, or set a specific point of resistance within the bike, that kind of thing. So I would personally go for something about the exercise and something about the recovery, because then I know that I'm talking about two different things within the variable set. There's a pretty big list on the mark scheme. State how the procedure could be improved to increase the reliability of the results. As soon as you see reliability, you know it's going to be repeats, but you don't just say repeat on its own, repeat with more individuals. Okay. Oh, don't know why I've left that one on there. Explain how the units of sweat production used in this investigation would allow a valid comparison between different individuals to be made. Okay, so here was our units. The average rate of sweat production in milligrams per centimetre cubed of skin per minute. Basically, because it's this per centimetre cubed, squared, it doesn't matter about the mass of the person that you're looking at. So it doesn't matter if it's a big person or a small person. We are looking at just a specific area of their skin. Okay, calculate the total mass of sweat produced per centimetre squared during exercise trial 3. Here we have our exercise trials and exercise trial 3. Let's just bring that one up. Here we go. So exercise trial 3 ran for 90 seconds and produced 0.32 milligrams per centimetre squared of skin per minute. Okay, we want the total that was produced here. So we have, oh sorry, I've still got a highlighter on, don't want that. So we have 0.32 per minute for 1.5 minutes. So I just times that by 1.5 and I get 0.48 megs per centimetre squared. Predict the rate of sweat production which would be expected in an exercise trial with a duration of 180 seconds. Okay, I can't tell you this one because this is on the basis of your graph. Okay, so this is an extrapolation from your graph, which is why your graph has to be pretty decent. The mark scheme will give a little bit of give. The mark scheme on this one gave 0.45 to 0.48. Okay, so that you have to take from the graph that you did. Okay, sweat production is a corrective mechanism used in the regulation of body temperature. Explain why maintaining body temperature within tolerable limits is important to the metabolism of humans. Right, you should recognise this graph. Being quite drastic with that one, but the whole point is it's asymmetric. This would be temperature, and this would be activity of enzymes. We need to be within, in fact, not even this range. We want to be up in the optimum. After this point here, you should recognise that we start to have denaturation of the enzymes, and so our activity drops off. So within tolerable limits is so that we can maintain the activity of the enzymes in the optimum, avoiding denaturation if it goes too high. And we also want it within tolerable limits because at lower temperature it's just running at a much lower activity rate, which is not going to be good for cells. Here is our SQE mark scheme. I say there is quite a lot of potential answers for these ones, so make sure that you're happy with each of the things you have. You'll notice here the marker is to ignore the prediction line, which you needed for down here. Sorry, there. This is the any value one. And yeah, just be careful that we have actually answered and not gone for the unacceptable, slightly vague answers. And that's another one done.